every time a vehicle is used, in good driving conditions as well as bad, and even when it's standing idle. A car meets the conditions that could spell disaster, that will certainly spell disaster, if the bodywork is not comprehensively protected against the dust and damp, the rain and smog. The ever-present elements that can crack all but the best defences and allow rust, the arch-enemy, to take hold. But with the weapons provided by modern technology, vehicles can be protected against these conditions so that the fear of corrosion faced by so many car buyers can be removed. This programme shows just how Fiat Auto are continuing to develop what is already one of the most comprehensive protection programmes available today. To understand just why the Fiat Auto anti-corrosion programme has become effective, we first need to know the enemy, to understand the factors that can cause corrosion. Rust is the chemical change that occurs when oxygen and water make contact with bare steel. So air itself, particularly when damp or humid, is the chief enemy. And there are other corrosive elements, such as sulfur and chlorine in the air, that can dramatically increase the impact of corrosion. Further important agents of corrosion are mud, that clings to narrow spaces in the body, and salt and grit scattered on roads in winter. These often act to chip the paintwork and expose the vulnerable steel panel to the air. The whole aim of Fiat Auto's anti-corrosion treatment is to protect the raw steel from exposure to the air. Not all parts of a car are equally vulnerable. The critical areas are identified here. They are spot welds, seams and internal areas of box sections, inside wheel arches, accidental damage points, and body panel joints. To protect these key areas and the vehicle as a whole, Fiat Auto deal with corrosion in three ways. By designing the vehicles to prevent inherent corrosion weaknesses being built in, by selecting and using the best protective materials, and by employing processes at all relevant stages of manufacture and distribution that continue to ensure that the protection applied is truly effective. At the design stage, specific measures are taken for the underbody, for movable sections and for seams to avoid problems such as moisture traps from the start. For example, open geometric shapes are employed and drainage channels are built in to ensure that there are no such traps in the finished vehicle. Additionally, horizontal seams and bonnet are designed to face the direction of travel, so corrosive particles cannot lodge in the seam. As part of the design process, prototypes are given the toughest possible for life testing. This is carried out at Fiat's own test centre at La Mandria near Turin. During 4 months of continuous testing, all conceivable kinds of driving conditions are reproduced and exaggerated. Cobbles, salt sprays, and mud fords. Following hard driving under extreme conditions, the test vehicles are completely stripped to identify any potential weak spots. From the materials side, body panels that are connected to parts that are crucial to the structure of the car are manufactured from pre-coated, corrosion-resistant zinc-chrome metal. But it's most probably in linking the right material to the most advanced manufacturing processes that the real improvements have been made. So that one of the areas where Fiat have made most progress in recent years is in the application of a series of no less than 10 protective barriers. The process starts during, not after, assembly. A special anti-corrosive sealant is applied along the edges of panels to be welded. Seen here as a green spot, this sealant prevents penetration of moisture into the seams. Indeed, recently the welding process has been replaced on doors, bonnets and boots with special adhesives that provide their own protection against corrosion. A zinc manganese phosphate coating is applied to produce a microcrystalline layer that provides the right basis on which to secure layers that are to follow. No protective coat will work if it is not bonded properly to the metal. The next coat is an anti-corrosion primer, applied by dipping the body shell in a vat of resin-based material, through which an electric field is passed, ensuring that even the awkward edges, joins and box sections are properly covered. This process has recently been further improved by changing the polarity of the electric field and by using a new polybutadiene resin to dramatically increase the penetration of the coating and to give elasticity, thus improving resistance to flying stones. Sealants are then applied to over 70 joins in the engine compartment and on the body shell exterior and underbody. This further closes the way in for corrosive elements. The underbody area is protected with a PVC coating that is highly resistant to damaging salt and grit and is impervious to water, unlike the bitumen material that used to be applied. The PVC is applied manually to difficult-to-reach areas, and the coating is baked on at temperatures of up to 140 degrees centigrade in successive stages. The next coating is applied to areas particularly vulnerable to chipping from flying stones. And with a conventional primer, this is baked on. Only now is the car given its final coat of colour. Even after the car has been finally painted, Fiat Auto's anti-corrosion program continues. Box sections are injected with wax to exclude damaging moisture, and to meet the special needs of British road conditions, a plastic liner is positioned under the wheel arch, covering the PVC coating. So, even if the vehicle is used in the most extreme conditions of temperature, humidity and pollution, the chances of corrosion penetrating the barriers are virtually eliminated. So we have seen that the best materials and manufacturing processes are used to provide comprehensive anti-corrosion protection. Zinc sealant, zinc manganese phosphate, cataphoresis, sealed joints, PVC underbody, anti-chip coating, primer, enamel or epoxy paint, wax undersealing, and plastic wheel arches. All Fiats or Lancias that leave the factories in Italy are designed and built to cope easily with all the corrosive conditions they are likely to meet. In design, in materials, and in manufacturing processes. Fiat Auto have ensured that each and every car they produce is capable of winning the fight against corrosion. Not unnaturally, many customers will still be concerned about what happens to a car between the time it leaves the factory and when it reaches the dealer. How is the vehicle protected during transit? Will the car be stored in muddy or other unsuitable conditions? The answers are clear. Each and every Fiat or Lancia imported into the UK is taken to a Fiat Auto importation centre at Yeovil or Newcastle. Here they are given a comprehensive final anti-corrosion treatment applied by highly trained personnel to all box sections, including the doors, wheel arches, the underbody areas, and the engine box section compartment. This treatment from Krillegard, one of the world's leading anti-corrosion specialists, is in fact a continuation of the factory process. And it is well worth noting that all storage is on hard standing. The Fiat and Lancia factories employ the latest processes and procedures to ensure full protection of the car's bodywork during transit and storage. This protection is not removed until final preparation of the car by the dealer for the customer. We hope that this program has provided you with the ammunition you need to present Fiat and Lancia cars as being amongst the best protected vehicles on the road today. Vehicles that literally have long life built in. Vehicles on which Fiat Auto can happily offer the unique 6-year warranty against corrosion penetrating the body from the inside. This warranty is an important selling benefit, but the customer must be made aware of the need for an annual check to maintain its validity. No other manufacturer offers more. The rest is up to you.